Welcome to Elevate Learn. In this tutorial, you'll master Python virtual environments and pip package management. These are essential tools that every Python developer needs to know. Virtual environments allow you to create isolated Python workspaces for different projects, preventing dependency conflicts. Pip is Python's package installer that lets you easily manage third-party libraries. By the end of this video, you'll understand why these tools matter, how to set them up, and best practices for professional development. Let's get started. Here's what we're covering today. First, we'll explore why virtual environments matter and how they solve real problems. Then we'll walk through creating and activating virtual environments step by step. You'll learn how to use pip effectively with practical commands. We'll cover requirements files, which are crucial for reproducible projects. You'll see real-world workflows and best practices that professionals use. We'll tackle common issues you might encounter. And finally, we'll work through complete project setup examples. This is a complete learning path for Python dependency management. Let's talk about why virtual environments are so important. Imagine you're working on two different Python projects. Project A uses Django version 3.2, while Project B needs Django 4.0. If you install packages globally, you can only have one version installed at a time. This creates conflicts. Virtual environments solve this by creating isolated Python installations. Each project gets its own bubble with its own packages and versions. This means Project A and Project B can coexist peacefully on the same machine. It also ensures that when you share your code with a team member or deploy to a server, the same versions run everywhere. This reproducibility is crucial for professional development. Let's understand how virtual environments actually work under the hood. When you create a virtual environment, Venv sets up a directory structure. This includes a bin directory that contains a Python interpreter and a pip executable specific to that environment. There's also a lib directory where packages are installed into site packages. The pyvenv.cfg file stores configuration. When you activate a virtual environment, it runs a script that modifies your path environment variable. This makes your shell use the venv's Python and pip instead of the system-wide ones. When you deactivate, it removes the venv from your path. This simple mechanism keeps everything isolated and clean. Now let's understand pip, the package installer for Python. Pip stands for Pip Installs Packages, and it's the standard tool for installing third-party libraries. It connects to PyPI, the Python package index, which hosts over 400,000 libraries. When you install a package, pip automatically installs its dependencies too. You can specify exactly which version you want using version specifiers. For example, Django == 4.0 means exactly version 4.0, while Django == 4.0 means version 4.0 or higher. Pip works seamlessly with virtual environments, installing packages into the isolated site packages directory. You can use piplist to see what's installed and pipfreeze to export versions for sharing with others. Let's create our first virtual environment. Use Python mvenv followed by the directory name you want. I'm calling mine myproject. This command creates the entire isolated Python installation. Then we activate it using the activation script. On Mac and Linux, that's source myproject/bin/activate. On Windows, it's myproject/scripts/activate. Once activated, your command prompt changes to show the virtual environment name in parentheses. This is your visual indicator that you're in the venv. You can verify by running which Python or where Python to see it's using the venv's Python. When you're done working, just type deactivate to exit the virtual environment. It's that simple. Here's what you'll see when creating and activating a virtual environment. First, the creation command runs silently with no output. Then when you activate, your prompt changes to show the venv name in parentheses. That's your signal that you're inside. When you check which Python or where Python, it points to the venv's Python executable, not the system one. The version check confirms you have the right Python available. Notice how the prompt includes the venv name every time you run a command while active. When you're done and type deactivate, the prompt returns to normal without the prefix. This visual feedback makes it clear which environment you're working in at all times. Now let's master pip commands. First, make sure your virtual environment is activated. You can tell by the parentheses in your prompt. To install a package, use pip install followed by the package name. Pip will fetch it from PyPI and install it. If you need a specific version, add the version number with equal signs. You can install multiple packages in one command. Pip list shows everything that's installed. Pip freeze is special because it outputs package names with exact versions. This is perfect for creating a requirements file that you can share with others. Just redirect the output to a file called requirements.txt. Later, anyone can use pip install our requirements.txt to install the exact same versions. If you need to remove a package, use pip uninstall. Here's what you'll see when using pip commands. When you install a package, pip shows download progress and confirms successful installation with a message. Pip list displays all your packages in a nice table format with versions. Notice how it includes pip itself and setup tools, which are fundamental tools. Pip freeze outputs in the special package == version format, which is exactly what goes into a requirements.txt file. You can see each package with its exact version locked in. This format is crucial because it ensures that when someone else runs pip install our requirements.txt, they get the exact same versions. No surprises, no compatibility issues. This reproducibility is why professionals always use requirements files. Requirements files are essential for team projects. When you have a venv with all the packages your project needs, use pip freeze to capture them. This command outputs every package with its exact version. Redirect it to requirements.txt. This file becomes part of your project. When you push to Git and share with teammates, they get this file too. They create their own virtual environment and run pip install our requirements.txt. This installs the exact same versions you have. No more works on my machine problems. Everyone has the same environment. If you add new packages later, just run pip freeze again to update requirements.txt. This simple workflow is professional practice that prevents countless headaches. Here you see the requirements.txt file created from pip freeze. The format is clean and simple. Each package name equals sign version number. This list includes not just what you directly installed, but all dependencies too. Flask installs Worksug, Click, and Jinja2 automatically, so they all appear here. When someone else runs pip install our requirements.txt, pip reads this file and installs all packages at those exact versions. The installation messages confirm each requirement is satisfied. This is how professional teams ensure everyone works with identical environments. Whether you're collaborating with teammates or deploying to production servers, requirements.txt is your guarantee of consistency. Let's walk through a complete real-world example. You're starting a new web application project. First, create a project directory and navigate into it. Immediately create a virtual environment. This is step 1 before anything else. Activate it. Then install all the packages your project needs. Flask for web framework, PyTest for testing, Black for code formatting, Pylint for linting, Doten for environment variables. Once you have everything configured, freeze the requirements. This creates a requirements.txt file at your project root. You also create a .gitignore to exclude the venv directory and cache files, but you commit requirements.txt to Git. Now when a team member clones your repository, they follow the same simple steps. Create a venv, activate it, and pip install our requirements.txt. They get the exact same environment instantly. This is professional workflow in action. Let's contrast wrong and right approaches to dependency management. The wrong way is installing packages globally with pip without ever creating a virtual environment. This works until you have project conflicts. The right way starts with creating a venv, then installing into it, then freezing requirements. The wrong way has different versions across team members' machines, causing mysterious bugs that don't happen elsewhere. The right way shares requirements.txt so everyone has identical versions. The wrong way commits the entire venv folder to Git, which bloats your repository and causes platform issues. The right way adds venv to gitignore and only commits requirements.txt. The wrong way pollutes your system Python with project packages. The right way isolates each project completely. The wrong way leaves new developers guessing what to install. The right way documents everything. The wrong way loses track of versions. The right way locks them permanently. Professional development demands the right approach. When specifying versions in requirements.txt, precision matters. The wrong way is just writing the package name without a version. This means pip installs whatever the latest version is, and next week's installation might be different. The right way uses equal signs for exact versions. Flask equals 2.3.2 means exactly that version every time. The wrong way uses greater than or equals loosely, hoping newer versions don't break things. They often do. The right way uses tilde equals for minor version flexibility. Flask tilde equals 2.3 installs 2.3 point anything, but never version 3. This gives safety while allowing patch updates. The wrong way has team members with different versions because they installed at different times. The right way ensures everyone matches because pip freeze captures exact versions. The wrong way forgets to update requirements.txt after installing new packages. The right way always reruns pip freeze to keep the file synchronized. This discipline prevents configuration drift. Here's your first quiz question. Why should you create a virtual environment before installing packages? Think about what happens if you install directly into SystemPython. Multiple projects share the same global packages. If Project A needs Django 3.2 and Project B needs Django 4.0, you can only have one installed. But with virtual environments, each project gets its own isolated space. Project A and Project B can coexist peacefully. Each venv has its own site packages directory. When you need to delete a project, just remove the directory, no cleanup needed. And when teammates install from your requirements.txt, they get the exact environment you had. Virtual environments solve all these problems. Here's your second quiz question. What's the difference between installing requests without a version versus with equals 2.3 1.0? When you don't specify a version, pip grabs the latest. If you install today and someone else installs next week, they might get different versions. With equal sign, you're saying use exactly this version. This is crucial for reproducibility. Everyone on your team gets the same code. Production servers run the same code. This is why pip freeze with exact versions matters so much. It's the difference between works on my machine and works everywhere. Final quiz question. What should go in gitignore and what should you commit? Never commit the venv directory. It's massive, contains compiled binaries, and is different on Windows versus Mac versus Linux. Anyone cloning your repo will recreate it from scratch anyway. Instead, always commit requirements.txt. It's tiny, pure text, and contains the exact instructions for recreating your environment. Also ignore __pycache__, .pytest_cache, and any .env files with secrets. Commit your source code, documentation, and configuration files. When someone clones your repository, they see requirements.txt immediately. One command pip install our requirements.txt, and they have everything. This is professional practice. Let's recap the essentials. Virtual environments are fundamental to Python development. They isolate packages per project, preventing conflicts. Always create a venv first before anything else. Then activate it. Now pip installs packages into your isolated environment. Use pip freeze to capture exact versions into requirements.txt. This file is your project's dependency contract. Share it with your team. Add venv to gitignore but commit requirements.txt. This keeps repositories clean while preserving reproducibility. Use exact versions for stability. Deploy with confidence knowing everyone has identical environments. This workflow is professional practice used in every serious Python project. Master these concepts and you'll avoid countless headaches. Virtual environments and pip mastery is worth the investment. You're now equipped to develop Python professionally.